So we'll start with the process. So we'll start with some algorithms. So we'll start with what are all the traditional techniques that people were following. And what is the difference between cyclical and seasonal component? Cyclical is something which happens at a regular period of time, and it is actually a predictable change. Say for an every 8 year, this cyclical, if it repeats the same pattern, then it is called cyclical. Seasonal is something across 2 different years you can check how the seasonal is behaving. So that's the difference between cyclical and seasonality. And we'll I think decomposition of time series, we have seen trend and all the other components. So what is a function? Decomposes the function to use that particular options. And now we'll talk about some of the average techniques. So moving average, exponential smoothing, weighted moving average. So how these things are happening. So I'll open some slides which I had created. So I'll take you through those slides. Okay. Okay. Generally, people on looking at the graphs, they'll tell whether it is an additive model or multiplicative model. So additive model is something where your seasonal variations are constant over time. So if you're looking at the variance level, it is equal across the time. So it is like the dispersion which is happening at every point is equal in this sort of graph. That is called additive graph. But when you're looking at a multiplicative graph, you cannot see a clear seasonal variation because these seasonal variations increases over time, and it decreases when the timeline is getting decreased. So if you're looking at this graph, it becomes difficult for you to find the seasonality pattern. So in these sort of data, getting a seasonal pattern is very difficult. So multiplicative model will not have constant seasonal variation. So if there is a particular data which is multiplicative model where you cannot find the constant variation, then what you have to do is you have to take a log transformation or a square root transformation. So if you take a transformation, then it becomes into it tries to scale up and it tries to have a constant variation. Okay. Or in another way, you can do a different thing. So we'll talk about all these things. So this is general about additive and a multiplicative model. So in additive model, you will have constant variances, and in multiplicative model, you will not have a constant variance. You would have a increasing seasonal variances. Okay. And now coming to simple moving average. Okay. Fine. Before this, generally in traditional time, how people had done a forecast? Any idea about it? Generally, like forecasting is something you are trying to predict the future values, right? For an example, generally people as a normal shop, like assume a kirana shop, which cannot afford a analytics company to work on their forecasting. So in those cases, what is the technique that they would apply to predict their future values? Any guess about it or any idea? In generally, right now I'm not talking about any forecasting algorithm. So if people are not knowing about forecasting algorithm and how they are forecasting their future. For an example, I hold a small shop where I'm just selling, say I'm just selling samosas, or I sell biscuits every day. Okay. And every day how I am managing my inventory. So every day I am just selling almost 200. So the last 1 week, if you are looking at, my sales was around 200 to 250. Okay. What would be my next day sales? In those cases, what would be your assumption, or what would be your logic that you would apply there? Simple average based on earlier days. Yeah, that's what generally people would take an average, and he would tell, okay, this is my future value. For an example, my first day sales was 45, second day was almost 50. I'll just put 500. I'll just put 480. Okay. If I ask a question in this case, what is the 5th day sales that is happening? So generally what they'll do is people will take an average of whatever data which is available. And they'll tell, okay, the next day sales can happen as 497 or 496. So as a nominal level, he can hold 500 in his quantity. This is a general way just people would do a forecast. In our olden days, people would do this sort of forecast. So now just tell me what is the advantage of it and what is the disadvantage of it while taking a general average. What is the drawback if I take a general average? If I take an average, because average is also one method to forecast your future, right? So if I take an average, what is the problem that I'll have and what is the drawback of normal average? Okay, there could be a spurious value. Yeah, some unexpected or an outlier value can be there. That is one problem. And what about other problem? And one more problem that I can tell is, okay, which will skew the result. Yeah, that would obviously skew the result. The general average, and what it will do is, for an example, and in this case, I don't consider any trend and I don't consider any seasonality. That is also a drawback. And I'm not going to consider any previous values, because for an example, general, as a normal human, what logic people would apply is, they look at the previous 3 days sales. So for an example, the last 3 days my sales was nearby 500. So what I will assume is, okay, today's sales will also be 500. But in the same case, if I take an average of over 2 years, for the last 2 years, because when I started a shop, people are not recognizing me. There they were getting almost 300. It started with 300, 200 as an average. Then when growing up with years, now it had come to 500. So in that case, if I take an average of over 2 years or 3 years, the past data, definitely average will not tell anything, because average is not giving any value to your data points. According to it, it is general and average, right? So it doesn't know what is your history and which history you have to give more importance. For an example, if I'm going to sell on the 5th day, what I'll do, I'll give more importance to my 4th day sales and the 3rd day sales. So based on my 3rd and 4th day sales, now I can have an assumption, okay, what would be my 5th day sales. So but in average you cannot give that weightage, right? Is that clear? That is a drawback of average. So now we'll talk about simple moving average. So in that case, what people had done is, I'm not going to take the overall 2 years of data. Instead of that, what I'll do is, I'll create a window size. Based on that window, I'll just forecast. For an example, in order to predict, okay, here there are like 10 plus 13. There are 13 data points. Okay, assume that there are 13 days. If I want to predict for the 14th day, what they are doing is, they are not going to take all the data points. Instead of that, they create a window of frame 10. So I'm going to consider, okay, my last 10 day sales is much important for me. So I'm going to do an average only on my last 10 day sales. So I'm going to predict the future values. So based on this, you're trying to moving this window. For an example, in this case, instead of taking all the 13 values, according to business, they consider, okay, the last 10 days is going to have an impact. So last 10 day, I'm taking an average and I'm going to find this value. If I take an average of all the last 10 days, so it is all the values 110. 110 divided by 10, it is actually nothing but 11. So now I found my next day is 11th. Now what I'll do is, in order to predict the 4th day, in order to predict the next day, what I'm going to do is, now I'm going to take my window size from here to my 11, the last 10 days, and I'm going to predict. So in the same case, now I found, okay, if I include this value, now I found this particular question mark, it becomes 13. Okay. Now in order to predict this, what I'll do, again I'm just shifting my frame. Now I'm taking this last 10 dates and I'm going to take an average. This is called simple moving average or a rolling average. Generally your averages are rolling. You're taking only the last 10 as your frame size and you're continuously forecasting, right? This is also one forecasting method. You're moving your window size and you're predicting. And can someone tell me what is the drawback of this simple moving average? Any drawback of simple moving average? I told the drawbacks of normal average. Now in that normal average, we had we had cleared one problem and we had came up with simple moving average. Now tell me, what is the advantage of simple moving average and what is the disadvantage of simple moving average? So in terms of simple moving average, what generally people would do is, for an example, these are all like 13 days I have. As a normal average, what you will do in order to find this, when you do a normal average, what is the logic you will do? You will take all this 13 days. You will take all this 13 days divided by 13. So you would get the average and that would be your future average. This is what generally you would do in normal average, right? Now in this case, I'm talking about moving average. So in moving average, what they'll do is, people would tell, okay, whenever I do a forecast, I give more importance to the last 10 days. So last 10 days would be my average. So in that case, what they're doing is, they're taking only this last 10 days. If my moving window size is 10 days, I'm taking this last 10 days and I'm taking an average. So what is my average? This is the result that I get, 11. So now if I want to predict the next value, what I'll do? Again, I'll take the data from here, from 6 to 11. I'll predict. Now that I had predicted this particular question mark is 12. Now in order to predict the next, what I'll do is I'll take from 12 till 10 I'll take. Okay, my window is actually moving. It is shifting one by one and to predict the future values. This is called simple moving average. My average is rolling. So I have a same window size 10. 10 is actually my normal window size. I am shifting. With this 10 values, I predict the next. Now I neglect one point here. I will add the predict and I predict the next value. So my window size keeps on moving and it does the process. This is called simple moving average. Okay. Now tell me, what is the drawback of simple moving average? What are the drawbacks of simple moving average? In a generic level, you can tell what are all the drawbacks that you are looking at this forecasting model. Does it capture trend or seasonality? It does not capture, right? It does not have any trend or seasonal component. That is one drawback. And what about the other? Okay, I'll tell what is the other drawback. So if you're considering all these 10 data points that I took, say for an example, this is the 10 data point that I took. Do I give any special weights? For an example, okay, this is my last day. So whenever you do forecasting, this should be given high importance. This should be given low importance, very low importance, and very, very low importance. So this importance level should decrease, right? For an example, in order to predict the future values, in order to predict my next day sales, which is the sales which is more important for me, my yesterday sales. And the previous day sales is less important, and the very previous day's data is very, very less important, right? So this importance level should decrease. But according to moving average, I am giving equal importance to all the 10 points, right? Do I give any weights to all these data points in moving average? Do I assign any weights or any importance level for the 10 data points? I don't give any importance, right? So I'm just taking a normal average for the last 10 days, simple. So here I'm not assigning any specific weights to the dates which is decreasing. So that's the drawback of simple moving average. So in order to overcome this particular process, people had started weighted average. They are going to assign some manual weights. Say now they are going to assign, okay, this is actually 5-period moving average. So I think we have talked about moving average. Now this is weighted average. For an example, now I'm going to manually assign weights to my earlier data points. For an example, just consider this data set which has 5 days. June 26th, 25th, 24th, 23rd, 28th. Okay. Here, for which data set should I give more importance in this data set in order to predict June 27? Okay. June 27 should be my prediction. So June 27 is my prediction. This is where I have to predict what is the sales. So in order to predict June 27, which data set I should give more weight? Actually June 27. This is the previous date. I give more importance. So what I'm assigning is I'm giving weight. I'm manually assigning my weight as 5. And for June 25th, manually I'm assigning weight as 4. For 24th, I'm manually assigning weight as 3, 2, and 1. Okay. And these are all the closing prices. So I'm just assigning all these weights and I'm going to calculate my future values. So I know that these are all the previous values. I'm giving high weight to my 26 and 4 less weightage, and it keeps on decreasing. And I'm assigning manual weights. And this 15 is nothing but 5 plus 4 plus 3 plus 2 plus 1. The overall weight. What is the proportion? What is the proportion of this particular value? That's what comes weighting. So 5 by 15. This is 4 by 15, 3 by 15, 2 by 15, 1 by 15. Okay. So 15 is nothing but 5 plus 4 plus 3 plus 2 plus 1. All the weights that you give. Sum of all the weights that you give. So based on this, if you're calculating your number into 5 by 15 plus 90.36 into 4 by 15 plus, if you're doing this process, you would get an average. Say you can get almost 92 or something. So 92 would be your 27th day sales. So this would be your 97. Okay. This is actually your weighted average. Here you had assigned some weights. In previous moving average, do you assign any weights? I'll show the previous window as well. In terms of 5-period moving average, now I have to shift my window size as 5. So in this case, what I'll do in moving average, just I'm taking all the 5 dates, I'm dividing by 5. This would be my sales. 90.6 by 7. 6 by 6 is my sales. So this is the difference between moving average and weighted moving average. Okay, clear? So the drawbacks of moving average is sorted in weighted moving average, right? Here I don't assign any weights. Here I have to give more. I have to give some good weight to this 26, less weight to 25. These weights will not happen in moving average. That's why I had preferred weighted moving average. Okay. How do we find the optimal period here? Okay. You're telling how can I fix my window size as 10 or 5? That's your question, right? Yes. So that is actually purely it comes from your business decisions. So generally you should ask your client what is the, because every company they would have a rolling forecast. Generally, if you're looking at all the companies even in India they don't afford an analytics team to predict their future demand. Most of the companies, 80% of the company, what they do is they do a simple rolling average to predict their demand. So they know what is their importance level. So should they consider the last 3 days or last 4 days? They would have been analyzing this for years. So based on that experience, they should fix their optimum size, window size. Okay, only the last 10 days will have an impact here, or last 5 days will have an impact, because these things purely comes from an business oriented side. Okay, you cannot fix your window frame from your analysis phase. Okay, clear? Because generally people would have a logic for their particular company. They would think, okay, only last 3 days is very important for me. So based on their business importance, you have to fix that window frame. So this is about moving average and weighted average. Okay. Now just tell me what is the drawback in weighted average. Okay. Sometimes the weights assigned may not be right, which will skew the data. Yeah, that is actually the valid point, because here I know 5, 4, 3, 2, 1. I had manually assigned weight. But these weights are not in a proper way, right? Because I don't know how much weightage should I give to this point and how much weightage I should give to this point. So that becomes a tedious process. Yeah, determining the weights and actually the outliers. Yeah, as Amani said, outliers. But generally what we'll do is initially when starting with the time series, we'll remove all the outliers. That is the general process. So your data that you're going to take here, it should not have an outlier. So I'll also talk about that, how to do it. Okay. But generally, in your time series data, you cannot have a outlier. Okay, you have to remove it. The one thing is weights, and the drawback is again it can also not capture seasonality or trend, because even it cannot capture trend or seasonality. So that is a drawback. So in order to overcome this particular problem, now we are going to see exponential smoothing. So I'll tell you what is exponential smoothing. I'll just tell you the calculation part as well, how this particular exponential smoothing is calculated and what is the procedure for it. I'll just open an Excel and I'll show you an example. So now what I'll do is, for an example, just assume I'll also try to put this in a calculation part with a theoretical concept. So I'll tell you how these methods work. Okay, assume this is actually the demand. This is for the day 1, demand 1, day 2. Okay, now I have to calculate for D7. So this is my problem, and we'll try to solve with exponential smoothing, so that we'll also have a good understanding of what is exponential smoothing. Okay, so meanwhile I also tell you the formula. What is the function for using a exponential smoothing? F of, because this is a bit calculation part also will come into picture. Just kindly go through all this calculation part. I'll take it. That's why I just took only dataset with only 6 numbers. Okay, this is the formula to calculate your values. So right now I'll just talk about alpha. So alpha is nothing but damping factor. So alpha is a damping factor which can range between 0 to 1. So whenever your weight is closer to 0, then you are telling you are giving more importance to your past values. So if I tell 0.2, here my weight is very, very high. Here it is less. It is very less. It is very, very less. It keeps on going. So until I move my alpha value towards 1, if I move my alpha value towards 1, it gives equal weightage to all my data points. Okay. So this is the just have a small understanding. Damping factor, it can always range between 0 to 1. So if you are dragging your values from 0 to 1, it assigns equal weight. Okay. if you're moving to 0, you're giving more weights to your previous histories. Okay, this keeps on decreasing. So this is all about damping factor. Now this is actually called alpha. Now just assume that in this particular case I consider my alpha as 0.2. I'll tell you the reason why, how to choose the alpha as well. But first we'll talk about the formulas, how it is calculated. For an example, this is the value which is f7, right? This is the value you have to forecast, which is f7. This is the value you have to forecast. So for D1, this is the values, and this is the value which you have to forecast f7. So we'll see how this forecast can happen using this particular formula. Okay. So based on this formula, what is the value that you have to calculate here? What is the value you need to get? It is f7, right? So if I'm substituting in this formula, what is t? If I substitute f7 here, what is the value of t here? It is 6. So actually it will be in a form that it is 6 plus 1, right? If it is x plus 6 plus 1, and what is my alpha that I took here? It is 0.2. Okay, and what is my dt? dt is not, what is d? What is t here? T is 6. So it will be d6 plus 1 minus alpha is nothing but 0.2. And what is my ft? Because I don't have any t value, so it is f6 actually. So f6. So I know what is my d6. So d6 is nothing but 27. So I'm going to substitute here. So f of 6 plus 1, that is f7, is equal to 0.2 into 27 plus 1 minus 0.2 into f6. Okay. So in order to get the f7 value, what is the value that I need to find? I need to find the value of f6, right? If I know what is the value of f6, then I can get what is my f7, what is the forecast, right? So now I need to find how I am going to get f6. So what is the formula to get f6? It would be 5 plus 1, right? Because this is actually a general basic algorithm which wherever you go you can apply here. At least if you have a good understanding of exponential smoothing, it helps you in understanding the process, how it is calculated. Okay. So in this case, what is the formula that I need to put? What is alpha here? Alpha is 0.2. And what is my dt? dt is actually, here I can find t is my 5. So I'll give d5 plus same. But here it would be f5. d5 is, here it is d5 is 26. 26. So here I need f5. So now I need to find what is f5, right? The same way now I need to, because to get f6 I need to know what is f5. So in the same way this equation keeps on going. For f5 this should be the formula. Instead of 26 it would be 28, and this would be f4. And now I need to get what is f4. So clear with this process what I am doing, because in order to get f4 I need to know f3. In the same way now I'll try to calculate f3. This is actually like a iterative process, it keeps on going until f1 will be f2. Okay, this is the maximum iteration that I can do. For f1, so for an example, to do all this process, what is the value that I want to know? to connect this entire process F1. So if I know F1, automatically I can calculate F2, F3, F4, F5, F6, and it keeps on going. So generally people, what they'll do for F1 is they'll take a normal average. They'll take an average. They'll take an average of whatever data points that you have. That will be your F1 value. So for an example, now this is my F1 value, which is 27. Now if I substitute 21, now I found that my F1 is 27. Because that I had calculated earlier. What is my F2 value? If I substitute F1 here, what is my F2? It will be 26.6. And now I'll substitute this F2 26.6 here so that I can get F3. If I do this process, I get F3 as 27.68, and I'll get the correspondingly. If I substitute F4 and F3 correspondingly, I can see many values coming here. 26.944. This would be. And if I'm talking about F5th value, 27.155. And F6 value would be 26.92. Okay. Now that this F6 value I can substitute in our final formula, right? I can substitute this F6 here. If I substitute X here, I can get the F7 value. So F7 is 26.94. Okay. Now I found my 7th day sales. This is actually the process. 26.94. So now this is actually my prediction. Okay, clear? This is how the way it is being calculated. This is how the final value is being forecasted. Okay. Now the important thing is what is the main advantage of it? So I told you, like, it has weights decreasing exponentially, because here we have to discuss how the weights are getting exponentially decreased. For an example, the first formula that I had is, I'll also tell you why the name is called exponential smoothing, because the weights are assigned exponentially. That's the reason. An example, this is the formula that I have. Okay. So in order to calculate this FT, what should I do? Or for an example, we'll consider here. Instead of 0.2, just make it as alpha. Okay, even it is 1 minus alpha F6. So instead of this F6, what is the value that I can substitute? I can substitute this entire formula, right? Instead of this, I can copy. Instead of this F6 value, I'm going to substitute this entire equation. Control C. I'm going to paste here. Okay. Now for an example, if you are looking at the weights, how it goes is, the weight goes in an exponential way, it get decreased. For an example, what is the first weight it is assigned here? So I'll just put this in terms of a formula now that it becomes clearer. For an F6, it is actually alpha into D6 plus 1 minus alpha into, sorry, this is alpha into 1 minus alpha. If I'm cross multiplying it, alpha into 1 minus alpha or I'll just give you in another way. Okay, this is the formula alpha into D6, alpha into D6 plus 1 minus alpha into F6, right? This is the formula we have, alpha into D6 plus 1 minus alpha into F6. So now I know what is F6. So F6 is nothing but alpha into D5 plus 1 minus alpha into f5. Okay, this is the formula, right, for f6. Is this formula clear for everyone? This is the formula for f7. Is this particular formula clear for f7 and f6? Now I am going to show the relationship. So instead of this f6, I can substitute directly my all these values, right? So what I'll do is I'll create another frame. Okay. Instead of this f6, what I'm going to do is I'm going to copy this formula and I'm going to put here instead of f6. Okay. Now just tell me what does f7 looks. f7 is equal to alpha into d6 plus what is this? How you can write this particular formula? An idea, alpha into 1 minus alpha d5 I can write, right? I can just multiply this alpha into 1 minus alpha. What I'm doing is alpha into 1 minus alpha d5 plus what is this 1 minus alpha into 1 minus alpha? What it becomes? Here this would be a square bracket. So first I'm just multiplying this alpha into 1 minus alpha into d5 plus 1 minus alpha into 1 minus alpha, what it becomes? So 1 minus alpha the whole squared, right? It becomes 1 minus alpha the whole squared f5. This is the formula, right? 1 minus alpha the whole squared into f5. So everyone is clear with this process. For an example, now I can tell, okay, how my weights are decreasing. For an example, what is alpha? It is 0.2. Now substitute alpha equal to 0.2. d6 plus 0.2 into 1 minus 0.2. Say it is d5 plus 1 minus alpha the whole square, which is 1 minus 0.2 the whole square into f5. Okay. Now can someone tell me these values? f7 is equal to 0.2 into d6. And what is 0.2 into 1 minus 0.2? What is 0.2 into 1 minus 0.2? What is the value? 0.2 into 1 minus 0.2? 0.16, okay. 0.16 into d5. And what is 1 minus 0.2 the whole square? Quicker answer because I think these are all simple logic, right? 1 minus 0.2 it will be 0.8. 0.8 into 0.8. What is it? Okay, 0.64. Just a moment, I'll just look at this again. Alpha into. Okay, I'm sorry. This would be actually alpha into 1 minus alpha the whole squared into d power 4. So alpha d6 plus alpha into 1 minus alpha d5 plus alpha into 1 minus. Here also again an alpha comes. If I'm substituting fy value, again there would be an alpha including here. So now I'll find alpha into 1 minus alpha the whole squared d4, right? So now it is d5. The formula would become here instead of fy, if I substitute, instead of substituting fy, if I also substitute fy value, what is the result that I will get? Alpha into 1 minus alpha the whole squared d4. d4 if I'm substituting the proper d values, and it keeps on going, right? Now just tell me alpha into 1 minus alpha the whole squared, because instead of fy again I'm substituting this d4 value. I'm replacing it with the entire formula. So this is the way that it will go. So Now just tell me what is the value here. Alpha into 1 minus alpha the whole square. 0.64 into 0.2, 0.128, right? 0.128 into D4. And it keeps on going. This formula would keep on going. So now just look at the weights, how it is calculated. Which is having the highest weight? D6 is having the highest weight, which is 0.2. And after that, D5 is having a less weight, 1.6. And D4 is having still less weight, 0.128. So if you're looking at the weights, gradually these weights are decreasing, right? D6 is given more weightage, and D5 is given less weightage, and D4 is given very less weightage. So this weightage, it keeps on decreasing, right? It keeps on decreasing exponentially.